we have this problem here, and so what do we do in our steps? We start by writing a t-chart with statements and reasons, and we label the first row 1, right? So let's go ahead and try that. We're going to do this right here. We got statements, and we have reasons. We have 1. We're going to write down all of our given statements. So it's AB is equal to CD, and then BD is equal to DE, and our reason is going to be given. Right? So that's all we have, and our first step here is to turn any congruent statements into equations using definition of congruent segments. So do we have any congruent statements? No, we have 2 equations, no congruent statements, so we skip step 3. Right. We move on to step 4. Are there any midpoints given? Are there any midpoints given? Well, if a midpoint was given, it would say midpoint here somewhere. It would say B is the midpoint of AD, or D is the midpoint of CE, but it does not say midpoint anywhere, so we are not given any midpoints. We skip step 4. We go to step 5, and now we're going to look at the figure, and if we're given 3 points on a line, we use segment adpos to create an equation. Seg adpos lets us say first part of the segment plus second part of the segment equals the whole segment. So we look at our figure right here, and do we have 3 points on a line? Well, we have a lot of points on 2 lines, right? But if we go ahead and cover up these 2 points right here, do we have 3 points on a line? Yes, A, B, and D are all on the same line. So we're going to go ahead and apply seg adpos on those 3 points. What does seg adpos let us say? First part of the segment plus second part of the segment equals the whole segment, right? Namely, measure AB plus measure BD is equal to measure AD. So let's go ahead and do that. So it's measure AB plus measure BD is equal to measure AD. Notice when we go to measure, we don't need the lines over the 2 points, right? So our 2 is going to be seg adpos. Okay. Okay, so now we're looking at those 3 points on the figure, right? We've got C, D, and E. So we're going to go ahead and apply seg adpos again to create another equation. So namely, it's going to be CD plus DE is equal to CE, right? First part plus the second part equals the whole part. So it's going to be measure CD plus measure DE is equal to measure CE. And so I'm going to combine that with my step 2, seg adpos, same reason. So now what do we do? Well, we went ahead and used seg adpos to create our equations. Last step here is substitution to try to get to the proof statement. What is our proof statement? AD equals CE, right? AD equals CE. We want these 2 to be equal to each other, right? How can we get those 2 to be equal to each other? Well, what we can do is if these expressions here are both the same, then we can go ahead and substitute in AD for this expression. Okay, so and then we can get AD equals CE. So that should be our goal, is try to get these 2 boxed expressions to be the same expression. Okay, make AD equal to the same thing that CE is equal to. So how can we do that? Well, CD is going to need to convert into AB, right? Can we turn this CD into an AB? Well, the only way that we could do that is if we have an equation that says AB is equal to CD. Okay? And if we have that equation, then we can use substitution and put AB here in the place of CD. So do we have that equation? Well, is this equation AB equals CD? No. Is this equation AB equals CD? No. Is this one AB equals C? Yes, we have it. Okay? So since we have it, we could take this AB and we could put it right there in the place of our CD. And I'm going to do that for step 3. It's AB plus, now my DE needs to turn into BD. And again, the only way that can happen is if we have an equation. This is BD equal DE. If we have that, then we can go ahead and take a BD and put it in here in the place of DE using substitution. So do we have that equation? Well, is it here? No, this is not BD equal DE. Is this one it? Yes, it is. BD equal DE. So I'm going to go and take this BD, since it's equal to DE. That means anywhere I see DE, I can put my BD. Anywhere I see my BD, I can put my DE, right? So I'm going to take this BD, and I'm going to put them right there. Okay? So it's D is equal to CE. So that is substitution. Okay, great. So now what do we have? We have AD is equal to the exact same expression that CE is equal to. You see that? Now we got them to be the same. namely AB plus BD. Okay, so how do we do this now? Now we're going to go ahead and substitute, right? And students are fine when substitution involves one term equal one term, right? We went ahead and took the AB, put it in the place of CD right here. Okay, you guys are fine with that. But all of a sudden, when there's two terms, your brains don't compute, and yeah, you have a lot of trouble with this. So, but it's the same thing. This equal sign here means anywhere you see this expression on the left side, AB plus BD, you could put CE. All right. Anywhere you put CCE, you can put this expression over here on the right side, on the left side, AB plus BD. All right. So anyway, I want to go ahead and substitute AD, right? And where can I substitute AD? It's anywhere I see this AB plus BD. And do I see this expression AB plus BD anywhere? Yes, I see it right here. So I'm taking this AD and I'm putting it here in the place of this expression because AD is equal to the same expression, right? So I'm swapping this one out and I'm putting what it's equal to, AD. That's my step 4. So it's going to be AD is equal to CE. So 4 is going to be substitution. And that is our proof statement right here. AD equals CE. Okay. However, up in the proof, we have a congruency statement. Down here, we have an equation. So we need to go ahead and convert this to line segment AD congruent to line segment CE. And my reason is going to be def of congruence. Okay. Definition of congruence lets us go from congruency statement to equation. It also lets us go from equation to congruency statement. And that's this problem.